Hi, in this video I'll explain a solved problem pertaining to the magnetic field created by a current flowing in a wire. In this problem, it states that there are two parallel wires and the currents are flowing in opposite directions. The value of the current is given. The wires are exactly parallel to each other and the separation distance between the wires is given, and we have to find the magnetic field at the point P, which is exactly midway between the two wires. Here's a sketch which I've also explained in my previous videos. The two red colored wires have currents flowing in opposite directions. The direction of current is shown by the pink arrows. The right hand thumb rule is inserted there, so you can see that the curled fingers show the direction of the magnetic field in terms of concentric circles. And so you can see that in the region between the two wires, the magnetic field from wire 1 is pointing downwards. The magnetic field from the wire 2 also is pointing downwards. Hence you see two sets of green arrows. Therefore, the magnetic field will essentially add up in the central region between the wires. In this sketch, you can see the current I1 on wire 1 equal to 10 amperes. The current I2 is flowing in the wire 2, also 10 amperes. And the point P is having the magnetic field pointing into the plane of the paper. And that will be true for any point P in between the two wires. On the left hand side of wire 1, the magnetic field will of course point upwards out of the plane of paper. On the right hand side of wire 2 also, the magnetic field will be pointing upwards outside of the plane of the paper. The distance between the wires, which is 5 centimeters, would be divided equally into 2.5 centimeters and 2.5 centimeters. With this, the general equation for the magnetic field vector will be B is equal to mu 0 by 2 pi into I by d, where mu 0 by 2 pi is a constant and I is the current and d is the distance, perpendicular distance from the wire. We now apply this general equation to the two magnetic fields. So the magnetic field at point P will be 2 times of the magnetic field due to wire 1 and due to wire 2. So mu 0 by 2 pi is 10 to the power minus 7 Tesla meter per ampere, and we put in the remaining values for I and D, convert D into meters, and then B works out as 2 into 10 to the power minus 7 into 10 divided by 0.025, and that gives 0.8 into 10 to the power minus 4 Tesla. Sometimes you can also convert this into microtesla, so that would be 80 into 10 to the power minus 6 microtesla. So the answer would be the magnitude of the magnetic field, which is 80 microtesla, and the direction of the magnetic field is also part of the answer, and we have to say that it's pointing downwards into the plane of the paper. This is the solution. Thank you and have a great day.